Now there are applications of using the distance formula as well. For example, looking at this shape on the coordinate plane, we can ask, how would you find the perimeter of this rectangle? Remember, the perimeter is the distance around the shape. So here we have a rectangle which is made up of all horizontal and vertical sides. So we can either just count the units, or we could find the distance between the points from the ordered pairs. So here, because the shape is made up of vertical and horizontal lines or line segments, let's just count the units. We have in a rectangle, the lengths will be equal to each other and the widths are equal to each other. So we really only have to count one length and one width. Here we have a length of 1, 2, 3, 4, 5, 6, 7, 8. And we have a width of 1, 2, 3, 4, 5, 6. So now we can find the perimeter by adding 8 plus 8 plus 6 plus 6, which equals 28. So the perimeter of that rectangle is 28 units. Now, again, this was very nice to find the distance because the sides of the shape, the rectangle, were all horizontal and vertical. We could just count the units on the graph. But most shapes do not have horizontal and vertical sides. For example, can we just count how many units long each line segment is in this quadrilateral to find the perimeter? Think of what's the difference between this shape and the last shape where we just did that process. Think about what other methods we could use to find the perimeter, or what we now need to fall back on if we cannot just count. Now you should see we're not able to count because these are not horizontal and vertical sides, but we can use the distance formula to solve this and other geometry problems. We can use it to find the perimeter, or even help with area, or anything that requires us to find side lengths that are not horizontal or vertical. So to find the perimeter of this quadrilateral, here we have quadrilateral ABCD, we need to use the distance formula to find all 4 of the side lengths, and then we can add them together. So we'll find the side length in blue, AB, we'll find the measure of the side length in green, BC, the measure of the side length of CD, and then the measure of the side length of DA, all using the distance formula and the 2 points between the segment. So here is that work, and it is a lot. You have to do the distance formula 4 times in this shape because there were no congruent sides, but here it is possible. You just, again, look at the points you're dealing with, find and identify your x1, y1, and your x2, y2, and then use that distance formula for all 4 times. So we get that the side length of AB, the measure is the square root of 65. The side length of BC has a measure of the square root of 17. We have the measure of side length CD is the square root of 37, and then the measure of the side length of segment DA is 5. And if we add all of those side lengths together and round to the nearest tenth, we get approximately 23.3 as the perimeter. So we can use the distance formula to find any side length of a shape as long as we know the x and y coordinates of the 2 points that are surrounding the segment for the side length of that shape.